motherboard once again. So what is motherboard? A motherboard is something that houses all the components, all the previous components that we mentioned, such as our CPU, our GPU, our RAM, our storage, and that's it. And it also does a little thing known as power management. It sends power. So what actually happens is there is a socket where you keep your CPU, and there are pins, the pins that like make contact with like either the CPU itself has pins or the motherboard has pins. In Intel based system, the motherboard has pins, while in AMD based system, the AMD CPU itself has pins. So it's needed for power, like to intake power for like the proper functioning of the CPU itself. So it delivers power. A motherboard delivers power as well, and it also acts like a house where other components are kept. And so the power it like a lot of the time gets, it's from a PSU. There is in the older systems there used to be a 24 pinned slot where you kept like your power supply. The power supply used to have cables, and the cable. So what will happen is the cable modules would be attached with the like the power intake of your motherboard, and then those attached, then like your whole system used to get power. And so we go on to the topic of power supplies. Power supplies, as the name itself like suggests, it supplies power. It takes the power from the wall, and then it transforms it. Like the power you get from your wall is AC, but like your computer cannot function on an AC current. So your power supply is, what it's doing is it's basically converting the AC current, the volatile current, to DC, like linear powers. And so then that power is later used in like the motherboard, then to your components. The reason why AC current is not like acceptable for like your system is because the fluctuation of the frequency of the power can damage like the system. Like if there is a high spike in like power, if there's like a high spike in power, then it can easily fry your CPU, and frying your CPU can make it like useless, meaning it's no longer useful. And then all it can be done is like it just needs to be thrown out. So that's the reason why the power supply also handles the work of conversion of energy. And then so that is what you generally need to know about like the computer components. Now we should also talk about the reasons why people build computers. A lot of people mostly build computers for doing office stuff. So meaning like you like you do spreadsheets, you do PowerPoints, you do that kind of stuff. And for these kind of stuff, you genuinely don't need a really beefy and expensive computers. And like for that reason, and also a point is that the GPUs that I talked about, the graphics processor cards, they are extremely expensive, like way expensive. And so what companies have done for like people who don't need like the power that the graphics card usually provides, is they create a iGPU or an APU. It's literally an integrated graphics in like your CPU itself. So what will happen is like your CPU has a die, the die I used to talk about, but the die is extended this time. So like let's say you have like one CPU which has, let's say, a die of 1 centimeter, 1 centimeter area of 1 centimeter. So then it'll be increased by like let's say 0.25 like area more, and in that 0.25 area they'll house like the GPU's processor unit as well. So now what you efficiently get is you get a CPU that has like both the computer unit and also the graphics unit. So it's really cost efficient, but like the graphics power is really low because like a small amount of die is being used, whereas in a GPU a whole big die used to be used. So this is just iGPUs. a lot of Intel based systems actually come with this thing. So a lot of like office workers favor Intel over AMD. AMD also has like its mobile version of these AI GPUs, but we are going to talk about it later. So so then talking about something else, yeah, there is like other uses of computer as well, just except of office work. There are like for playing video games, for streaming, for doing online activities, and for like doing gaming is really intensive. It takes a lot of resources. So playing like the new titles, these titles are like very demanding for system, like very demanding in resources. They take up a lot of resources of your computer, but they also provide some mesmerizing forms of art. So so for playing games in a decent setting, you need a decent computer. It's mostly like just having a GPU. Having a GPU should like having a discrete GPU should like be your top priority if you are trying to game. And streaming while playing games, you need a even more beefier system because you are efficiently streaming your stream, and it also like you're streaming your stream, but you're also playing the game. Playing a game already being demanding itself, so you need a beefier system. And like for doing like match scale calculations, such as like let's say NASA level calculations, you need very beefy computers, like computers that are like 50 years ahead of the consumer computers you get. And to reach that level for a consumer, what you have to do is basically buy the top end shelf components and just buy a lot of them in bulk and just add them. This is but like companies already have specified stuff for them. Nvidia, the GPU company, has a series line called Quadros. Those are more, they are more inclined to doing like all the calculations for like your system. And so like that's all that you need to know about computers. Well, computers are really fascinating for me. It fascinates me like how many like how incredible they are. Like it's mind blowing to see that something small as your phone actually is complex as well. Like how many steps it has to go through to give you something like just showing you an image. Like how much amount of like how much amount of science has gone through it, how much amount of dedication and hard work has been poured, and like just give you a system. And just like just thinking of the complexity of like the system itself, like a calculator in itself is pretty complex, but like a computer is like 500 times more complex than that, and that itself is like really mind-blowing to me. So well, that is all you need to know about your computers. And then then we have to move on towards operating systems. So what are operating systems? Operating systems are basically what you use. It's the interface that you use like to use the computer resources, like what like like your Windows, like your Mac OS, and like your Linux operating system. These are three different operating systems, but they are very different. Windows operating system, there's the Windows 7, the Windows 98, the Windows XP, and then like the new Windows 10. It's not new, it's pretty old, but still Windows 10. So the difference between like Windows and Mac is Windows is like from the company Microsoft, while Mac is it's actually an open source Linux based operating system. It's specifically made for like Mac operating systems only. So it's basically made for Apple only. By like it's an open source, so like having an open source means you can play with the code itself. And then there is Linux. Linux is literally an open source operating system, so you can like there's lots of variants of it. There's Ubuntu, then there's Kali, then there's many other forms such as these. But you don't need to go in depth. All you need to know is there are different types of operating system, and you can like in your system, let's say you bought a new laptop, like let's say you bought the new Apple laptop, you're not forced to only use the Mac operating system, you can like try with like the Windows operating system as well, and also the Linux operating system as well. So there is more options. And I think that should conclude our class for today. There's like not a whole lot that we could talk on this time, so I hope we can I hope you enjoyed it. Thank you very much. Lovely evening to every one of you present here. Today I'll be starting a new chapter for our online class, and that subject will be computer hardware. Well, you might have known we live in a bizarre time where like computers have become an integral part of our day-to-day lives. Computers small as our phones, but as strong as 5 years ago's computers. Computers have come a long way, and today I'll be teaching you about um, the core computer, the big box one, the one we call our home setup. And so that will be our subject. I'll teach you about the components, the main use of components, the companies that make the components, and the type of component that you can get. So let's get started. So first and foremost, like in a computer, first we have to figure out the components that we actually find in our computer. The first being the CPU. A CPU, or a compute processor unit, is something that computes information, or it gets data, and then it's like cycles the data and it works with the data, and then it releases the data or the result. That's what CPU does. First being CPU, then the next being your GPU, or graphic processor unit. Third being your motherboard. I'll just write MOBO for short. And the fourth being your storage. Then we also have the RAM, or the random access memory. Storage is also known as ROM, but we mostly just call it storage for like ease of knowing stuff. And then in sixth we have power supply unit, or PSU. And in seventh we have monitors and other peripherals. Damn. So now that we have then you also have the casing, but casing and cooling is something that is not an integral part of what makes a computer a computer, but more as an aesthetic thing, and more for like the thermals. So we'll start with like the order that I have stated here. So we'll proceed in the order that I've listed here. So first, let's speak about CPUs. CPUs, or as I just told, computer processor units. So what they do is they process data, but the data that is actually fed by RAM will it'll all connect together at last, but for a while you'll stay confused. So please be attentive. So the main task of a CPU is to take the data, like take the main data that let's say I'm a user and I want a certain data, like let's say I want a picture of my firstborn to be presented. And so what will happen is the storage will pick that data up, and then it will send it to the motherboard. The motherboard then will send it to the RAM. The RAM then will send it to again to the motherboard, and from the motherboard again to the CPU. So what the CPU does after that, it is encodes it, then it decompresses the picture, then it recompresses the picture, and then it gets like a bigger picture, and then it shows it to the screen that is again sent to the monitor, and the visual aspect of it is actually got from the GPU.
Hello, Pasang. Sir, um,
Sir, you are muted, sir.
sir, you're lagging, I suppose.
Sorry for the inconvenience. And so as I was talking about, so then the RAM feeds the CPU the data, and then the CPU and the GPU work together the CPU gets like all the numbers, the zeros and ones processed, while the GPU okay, turns the zero and ones into like the pixels, and then it's shown in the monitor. So this is a really like layman's term level explanation on what actually happens for like processing or like actually showing a picture itself. So then we were talking about CPUs. So now that we know what a CPU does, so then we have to talk about its internal stuff as well. So the internal stuff of a CPU is a CPU consists of like most of the time we call it cores. Cores are your essential part. So this first, I'll not erase this. It's really like needed. So wait for a while. So what cores are? Uh, let's tell this is a CPU, and then these are like cores, and then there are threads, and then there are information. So easy. Now you might be puzzled by the new terms that have came in your way. The three terms being course, threads, and info. So what happens is, if you are thinking like comparing this to a business, CPU is like the workplace where like cores or like your people, the people who work for your company, they come to do the work. Information is fed towards threads. Threads being, let's say if you are working in a chocolate factory, so what a core is a person, and let's say their work is to wrap, let's say the chocolate in a, so the chocolate comes, they have to wrap it and they have to send it again. So so like the one thread, the thread becomes like the one alleyway from where the chocolate can come, chocolate being the information here, and the person becoming the core. So a thread is one alley from where like the information can arrive. And a lot of computers nowadays have hyperthreading. Hyperthreading means two threads for one core, meaning a single person can work at two sides. But it doesn't mean that a computer can actually work two times faster. It more or less means, because a computer is all about reaching that 100% efficiency rate. So what happens is, so like let's say a person quickly finishes like wrapping up the chocolate from one alleyway, and then it's literally just waiting for a while for the chocolate to again come to its place so it can work on it. Well, this would be a major waste of time, and no business wants to waste time on getting wasted wages. So what they do is, with hyper threading, they have two ways from which the chocolates can come. So as soon as the person finishes chocolate from one alleyway, they can work on the second alley. So this is like the essential use of hyper threading, and it also doesn't mean that your stuff gets doubled. So now we are moving towards the, now that we know what a CPU is, we can now move towards what okay, CPU companies are. So there are two major CPU companies. They are, one is AMD, or Advanced Micro Devices, and there is second, Intel. These are like the major players. Well, there is these are for x86 architecture types chips. The one you see on your phone are x64, and like in your iPad and those is all x64. This is a different architecture, so we are refraining from those. So in the x86 market, we have the two CPU types, which is AMD and Intel. Intel is known for its long reign as the king of like the CPUs, while AMD has become like, it has it's it has had a renaissance, and it's now like peaked to such extent that it beats Intel, and it actually shames Intel for even being a CPU company. So the thing about these two companies have different core ideologies. The AMD ideology is to put in more cores, more cores in a set amount of die, while Intel is about providing more amount of like hertz or core speed into like a certain amount of die. The thing with adding like, so you might be thinking, well, why doesn't Intel do both, like add more threads? or add more cores, and also increase their carry speed. Well, the thing is, the bigger the die size, a die is literally a area in which like computer processor units are kept. So the more, the bigger the area is, the higher the rate of like failure, the higher the chances of failure. So what actually happens is, the bigger you make the die, the more like, it's like more easier for error to appear.